In this lecture, we're going to see how we can use function pointer type aliases together with templates to make things much easier to work with. Here we have a simple code example, and we are setting up a type alias to a function template which returns bool, and it is going to take two things that are similar by reference. So you can pass in integer references, you can pass in std string references, you can really pass in anything. The only requirement is that the return value is going to be bool, and the two parameters you take by reference have to be the same. So this is a template function pointer type alias. Once we have this in place, we can set up another function template, for example, which gets the best things in a collection of things. You can see that we are making our get best function much more general in that it can really work on anything, not only on std string like we had in a few previous lectures. Now we can get in the body and really do whatever we did before. We're going to grab the best element and make that the first item by default. We're going to loop around trying to find a much better item and storing that in our best variable here. And at the end of the loop, we will have the best item stored in this best variable. We're going to return it to whoever happened to call this function to get the best element in our box container collection. Now, at runtime, when we call this function here, we will specify which type our box container is storing, and everything is going to fall in place. We can use this function on a box container of std strings. We can use this on a box container of ints. We can use this on a box container of dogs or items. The only requirement is really to be able to compare the items that are contained in our box container using this comparator here, which is going to be taking two items. And this is really cool. Okay, so we can start and use this on our box container containing std strings. We can specify our larger in size callback, and the compiler is going to use this with our box container of std strings. The only requirement for this to work is that the type that is stored in our box container is the type that our callback here is comparing. Again, this can also work using our greater lexicographically callback, and everything is going to fall in place here. We can set up a box container that contains ints, and we can guess the best element using this callback here, and we're going to see that it is going to work. It is also possible to set up a templated callback function, and this is going to be much better because you won't have to set up multiple callback functions. The only requirement is that the types that we are comparing here support the less than operator, and if you have that operator, this function here is going to work and get you the smallest element between the two elements that you are comparing, and we can use that in our main function like we do right here. One other thing you should know is that templated type aliases don't work with type def, so you are limited to using the using syntax. And this is another reason you should really ditch type def, because it has no place in modern C++ code. Now that you know these things, we're going to head over to Visual Studio Code and play with this a little more. Here we are in our working folder. The current project is function pointers type aliases with templates. We are going to be reusing the code from the last lecture, so let's grab all the files in here. We are going to put them in our current project. And let's open this little guy in Visual Studio Code. We have our main CPP file, which is including box container. We don't need all these things we had before. We are going to put in new versions of this, so we can take out all these functions we have in front here. And we can take out whatever we have in the main function to keep it super clean. And this is going to be our starting point here. Now, the main topic is that we can set up a type alias that uses templates for function pointers. And the syntax to do that is what we have here. This is our type alias. We say using compare t, and the t here really is meaning that this is a template, but you can name this whatever you want. And we're going to specify our function template to the right. You see that it is using our template parameters, so this can really work for any other type. We will be able to use this comparator to compare different types. For example, we can compare strings, we can compare integers, we can even compare our own custom classes like dog or car or whatever it is we want to do. Down here we have our getBest function adapted to work with our templated type alias. It is going to be working on a box container of t, and we will be comparing those t things using our comparator here, which is also templated on the template parameter here. Once we loop around trying to find the best thing, we will find it and store that in our best variable, and we're going to return this to be used by whoever might have called this function here. This is the setup we are working with. Now that we have our getBest function in place, we need a bunch of callbacks we can call it with. We are going to go down and set up a bunch of callbacks we can use with our function here. We will have one that compares strings and returns which one is greater than the other in terms of size. We will have another one which compares strings lexicographically, and we will return here. We will also have another one which compares integers, and we will use this on a box container that happens to contain integers, as we are about to see. So we can go down in our main function and set up our code. We're going to set up our familiar box container of std strings. The content is going to be "the sky is blue, my friend," and we will get the best string in terms of size using our larger in size callback. This is going to give that to us, and we will print it out. We will also get our greater string lexicographically, and we will print this out. Notice that we are using our getBest function, which is going to be templated on the type that we pass in. So it is basically going to be templated on the type that is contained in our box container. So if we have a box container of ints, this is going to be comparing integers. If we have a box container of std string, our comparator here is going to be comparing std strings. And that's what we have down here. We have a box container of std strings, and our callback larger in size is also going to be comparing std strings, as we can see to the top here. So we are going to be looping around in this box container trying to find the base string. We're going to find it, return it, and print it out here according on these callbacks that we are passing here. Hopefully this is making sense. We can pass this through our favorite compiler. We're going to use GCC. The build is going to be good, so we can not clear. Let's bring up our PowerShell window to be able to do that. Now we can clear and run Rooster. We will see that our best item in terms of size is friend. Our best item in terms of where it appears in alphabet is sky, and this is the data that we expect. And we have the flexibility to have one getBest function that works on the different types. Here we just use the box container of std string, but we can set up another box container which is going to contain integers. So if we go down and do something like this, we're going to set up a box container for ints. It's going to be containing 1, 3, 23, and 4. And we can print the best item in terms of this callback. So we're going to find the larger int. So let's do something like this. We're going to say stdc out larger int, and we're going to print that out using our getBest function. We're going to get the best in our box container of ints, and we will be using the larger int callback that we have on top. I think this is going to do. And if we do this, we hope to get 23 printed out because it is the largest integer in our box container of ints here. Let's pass this through our favorite compiler, which is GCC. The build is going to be good, so we can clear and run Rooster. And our larger int is going to be 23. Our code is really working as we want. If we go in here, for example, and say ints add and add 233, and build again, we will find that larger integer and make it our best element, and we will print that out. So clear Rooster, and we have our larger int here. This is working as we want. The last thing I want you to see is that it is also possible to set up a templated callback function if you need to do that in your C++ program. And the syntax is really simple. This is a template function which is going to be comparing two t's by reference, and we will basically use the less than operator to compare these things. So we can use this little guy to target the smallest element in our container and print that out. So if we go down, for example, and comment out what we had here, and we will target the smallest integer, we can copy the code here and put that below. And if we say smaller int, we're going to say smaller here. And the compiler is going to instantiate our smaller function template for ints because the box container contains integers and everything is going to fall in place. We will see that we will get the smaller integer printed out, and that's going to be our 1 here. Let's build and pass this through our favorite compiler. The build is going to be good as we see here. We can clear and run rooster. And we're going to see that our smaller int is 1. If we change this to be a 10, for example, our smaller int is going to change to this 3 here. Let's build and see if this is actually the case. We can pass this through our compiler. The build is good. So let's clear and run rooster. We will see that now the smaller int is 3. Our function template is working exactly as we want. And we are using this as a callback in our get best function call here. This is all I wanted you to see. This is all I had to share in this lecture, showing you that it is possible to set up type aliases for function pointers and make the type alias templated. This is going to make your code easier. Make use of this feature if it is useful for whatever it is you are designing with C++. One thing I should bring to your attention again is that it is impossible to use type defs with templated type aliases like we are doing here. That's a limitation of type defs, and it is another reason you shouldn't really use type defs in modern C++ code, because that syntax is really meant to die a slow death as C++ progresses in the future. We are going to stop here in this lecture. In the next one, we're going to learn about function objects. Go ahead and finish up here and meet me there.